Hello friends, in this video we will study about solubility and solubility product. So let us start with solubility, okay? So it's very simple. So the solubility is in 1 liter of the solvent, what is the maximum amount of a solute that can be dissolved at a particular temperature? Okay. So what's the definition? The maximum amount, the solubility. Okay. So what next? So what should be the unit of solubility then? So unit should be, you are saying maximum amount. This maximum amount of the substance may be taken as taken in gram, 10 gram per liter, or generally we express it mole per liter. So So this is about your solubility. Next we will move to solubility product. Okay. Consider the dissolution of a sparingly soluble salt like silver chloride. So why we are taking a sparingly soluble salt will be clear little later. So for our simplicity, let us take a sparingly soluble salt, silver chloride. So as you know, silver chloride dissociates into Ag plus and Cl minus ions, and dissolution process undergoes a reversible process, right? And after some time, it comes to an equilibrium. We can apply the equilibrium. That means we can write for an equilibrium constant for this reaction. So equilibrium constant for this reaction will be K is equal to Ag plus HCl concentration. Concentration of HCl. So one most important thing is to note that, once you get the equilibrium between the dissociated ions and the undissociated silver chloride molecule, then your ions of the Ag plus and Cl minus are fixed, because at the equilibrium we studied in the previous class at equilibrium concentration of reactants and products becomes fixed. So so the concentration of the ions remains fixed, and concentration of the undissociated HCl, which is present in solid state, also fixed. So these are in aqueous state and these are in aqueous state. This is in solid state. Okay. So since this is a constant, we will now develop this equation in this way, that the equilibrium constant will be multiplied by this undissociated silver chloride to give Ag plus concentration into Cl minus concentration. Are you getting me now? So this is, you see, constant into constant giving rise to another constant. That's what we call it solubility product is equal to Ag plus and Cl minus. The multiplication, the product of the silver ion and chloride, product of the ions at solubility, hence called solubility product. So what is that solubility? We have already mentioned the maximum amount that can be dissolved. So maximum amount that can be dissolved means maximum number of ions present in that solution. So now the solution is a saturated solution, because in a saturated solution your ion concentration is maximum, and you cannot increase the concentration of the ions more than that saturated Are you getting it? So Ksp is equal to, that means the solubility product is the product of ions of the solute of a saturated solution. So it is the product of, it is the saturated solution. Now we can come to the question why we took silver chloride, why we took the sparingly soluble salt. Because sparingly soluble salt, as it is very feebly ionized, so on addition of little amount of salt, you are very sure to get a saturated solution. This equation applies to strong electrolyte also, but provided the solution should be saturated. Even in case of sodium chloride, when the this is a saturated solution, there can be the solubility product. This is equal to the product of Na plus concentration into Cl minus concentration. Are you ready now? Let us have a relationship between solubility and solubility product. So, relationship between product. Once again, take that silver chloride dissolution. AgCl gives you Ag plus Cl minus. Whole of the silver chloride is not dissolved, and a part of it is dissolved into ions. Say we have already studied about solubility, the maximum amount of the solute. So if the maximum amount of silver chloride that can be dissolved in a solvent is S, that is S moles per liter. If this is S moles per liter, 1 mole of AgCl is dissociated into 1 mole of Ag plus and 1 mole of Cl minus. So S mole per liter means S mole of AgCl is dissociated into S mole of Ag plus and S mole of Cl minus. And once the equilibrium is established, so Ksp is nothing but the product of concentration of ions. So the concentration of Ag plus is S, also the Cl minus is S, so Ksp is equal to S square. This is the relationship between the solubility and solubility product of AgCl. Are you getting it? So if you are taking another solute, you will get another relationship. Like if you are taking, say, PbCl2, you are taking PbCl2. So this will give you Pb2 plus 2Cl minus. And we have already studied in chemical or ionic equilibrium, 1 mole of PbCl2 gives 2 mole of Cl minus ions. So if maximum amount of lead chloride is S mole per liter that can be dissolved, so if it is S moles per liter, so it will be formed as S, it will form as 2S. So now you can write Ksp is equal to, you can now apply the equilibrium, and because we have started the solubility product after applying the chemical equilibrium, so you can also apply the chemical equilibrium to this reversible reaction and then can find the equilibrium constant and multiply the solid PbCl2 concentration with the K to get the solubility product. That will give you Pb2 plus concentration into Cl minus concentration power 2. Okay? Power 2. Because in the equilibrium, the coefficient becomes the power. Law of mass action. Okay? So Ksp will do this. So it's equal to the concentration of Pb2 plus is S and the concentration of what? Cl minus is 2S. Its square. So this is 4S square into S is equal to 4S cube. So the solubility product of PbCl2 and solubility are related like this. Are you getting it now? Numericals on solubility product. So the question is, if the solubility product its solubility, what will be its solubility in a XM solution of calcium chloride? The question is this: what to do and what to achieve? What is given? Given is the solubility product of AgCl is this, and asking what will be the solubility of that AgCl when it is put into solution of X molar calcium chloride. So what to do? You see, how to answer? So the solubility product of AgCl is Ag plus and into Cl minus. Okay, is equal to Ksp. The solubility product of AgCl is equal to Ksp is equal to Ag plus into Cl minus the concentration, right? And the dissociation pattern of AgCl is like this. If S mole of silver chloride dissolves at maximum, then S mole of silver and S mole of chloride ions are formed. S mole of silver and S mole of chloride ions are formed. Okay, so the solubility product, is equal to Ag plus into Cl minus concentration, H into S is equal to S square. So the solubility will be Ksp to the power half. Okay, Ksp to the power half. But you are adding it to the X molar calcium chloride solution. Thus, calcium chloride dissociates into Ca2 plus 2Cl minus. In the question, it is given that calcium chloride is present X molar. For X you can take in the numericals 2 molar, 3 molar, 4 molar like this. So X mole is present. So similarly, like the dissociation pattern, you are going to get X mole of Ca2 plus and 2X mole of, as we did in chemical equilibrium and ionic equilibrium, X molar of calcium chloride will give 2X molar of Cl minus. 2X molar of Cl minus. Okay. So now the total Cl minus concentration is already present S, and now 2X becomes, it was present as S plus 2X. But since solubility product of AgCl is always fixed, so Ksp is equal to Ag plus concentration into Cl minus concentration. And Cl minus concentration is not merely this S, it is more than that, S plus 2X. Since chloride ion has been increased and this is to be kept constant, so it should decrease. Okay. So then the molar solubility of silver chloride is nothing but the concentration of Ag plus in the solution. So what we get? So Ksp is equal to Ag plus concentration, okay, into Cl minus concentration, that is your S plus 2X, right? Now Ag plus concentration, whatever the amount of Ag plus will be in the solution, that will be the maximum amount of silver chloride dissolved in the solution. and this is the important thing to be noticed. Okay, so the Ag plus ion concentration, which is equal to molar solubility is equal to Ksp by S plus 2x, and thus, as you know, this S is very small. So this can be neglected. Why? HCl is a sparingly soluble salt. Its solubility is very minimal. So finally, if you know the solubility product, if you know this X, what molar of calcium chloride, then Ksp by 2x will be the molar solubility of Ag plus. Molar solubility of what? Molar solubility of AgCl in X molar calcium chloride. I hope you could understand. If not, you may ask me questions in the comment section. Thank you. In the next video, we will discuss about the condition of precipitation. In the next video, we will see how the solubility product and ionic product affects the precipitation process. Thank you. We'll discuss in the next video.